You're all welcome to today's technical session. So today we'll be exploring how to deploy LLMs in healthcare responsibly, and as well addressing the bias, privacy, and robustness. So to start, we're going to dive. We have for today's session. So the first one is, what is an LLM? LLM is a large language model. It's a type of artificial intelligence that can understand and generate human language. They are trained on massive data sets of text and code, enabling them to learn patterns and relationships in languages. LLMs can perform various tasks, including text generation, translation, question answering, and more. Then we're also going to look at just for a better understanding.
Large language models in healthcare help process medical data, improve documentation, and support clinical decisions. These AI systems analyze vast amounts of information, making workflows more efficient and giving medical professionals better tools to care for patients. Large language models in healthcare help process medical data, improve documentation, and support clinical decisions. These AI systems analyze vast amounts of information, making workflows more efficient and giving medical professionals better tools to care for patients. So how do these powerful AI models work in healthcare? Large language models, or LLMs, process vast amounts of medical data, helping doctors streamline documentation, summarize patient histories, and even assist in diagnosis by identifying key health indicators. AI chatbots powered by large language models are improving patient engagement. They provide 24/7 support, answer medical questions, and help manage appointments and medication reminders. Large language models are also accelerating medical research. By rapidly analyzing clinical trials and scientific papers, these AI systems help researchers identify new treatments and advance drug discovery. Despite their benefits, large language models come with challenges. Issues like AI bias, patient data privacy, and integration difficulties with existing healthcare systems must be carefully addressed to ensure safe and ethical AI deployment. The future of large language models in healthcare looks promising. With ongoing improvements in AI transparency and human-AI collaboration, these models will continue to enhance patient care and medical research. Want to explore how AI
Okay, I hope with that video you have a better understanding of what LLMs are used for. Now, for the next definition, we'll be looking at the bias that we'll have in LLM deployment. So like from the definition, we'll see that there are unintended favoritism in model outputs due to skewed training data or model designs. So the question now is, what causes bias? We'll talk about LLMs. So number one, we'll talk of training data. LLMs are trained on vast data sets, often sourced from the internet or textual repositories. These data sets may reflect existing biases such as gender stereotype, racial stereotype, or cultural biases. Then we'll have model architecture, the underlying architecture of the LLM and the assumptions made during its design can also contribute to bias. We also have the human input part of it. The prompts and instructions given to the LLMs by users can also influence the model's outputs and introduce bias to the system. So next, we'll be looking at the privacy in LLMs, which have to do with the risk of data leakage. So privacy in large language models refers to the protection of sensitive information from being inadvertently revealed or compromised during the training, use, or storage of LLMs. This includes protecting the privacy of individuals whose data is used to train the model, ensuring that the model's outputs don't reveal sensitive information, and safeguarding the confidentiality of data used in interactions with the model. Privacy is non-negotiable when it comes to LLMs. Then we'll be looking at robustness of LLMs. Robustness in large language models refers to a model's ability to maintain performance, accuracy, and reliability, even when faced with variations in input data, context, or adversarial attacks. So model resilience against adversarial attacks and uncertainty in clinical environments is very, very important. Why is robustness important? It's crucial for LLMs because it ensures that they can be relied upon in real-world applications where inputs are often noisy, incomplete, or intentionally manipulated. In situations like customer service, where users may not always phrase their questions perfectly, or in security-sensitive areas, where malicious actors might try to exploit the model, robustness is essential for maintaining accuracy and trustworthiness. So by ensuring that the model remains reliable under a variety of conditions, as we've mentioned earlier, robustness helps build trust in the technology. It helps the users have trust in what they are using. Okay, we'll now look at the history of LLMs in healthcare. So looking at the historical evolution, starting from 1960s, we have the rule-based NLP for medical coding, the expert systems for decision support that came up in 1980s. They'll have the statistical NLP for EHR interpretation that was also discovered in 2000. Then in 2010, it presents, that's from 2010 to present, we start having transformers models that enabled unstructured data analysis. So we start having better resolutions of LLMs from then on. Now, the key milestones in this history of LLMs. From 2017, we had transformer model introduced by Vaswani et al. Then in 2018, BRT by Google introduced their own LLM, enabling fine-tuning for medical questions and answers. Then 2018 to 2020, we saw the rise of GPT series, which was applied in medical NLP tasks also. Then in 2020, particularly, GPT-3 demonstrated potential in clinical notes generation. Then in 2021 to present, we start having more adoptions in diagnostics, EHR summarization, and patient interaction. From 2020 to 2022, rise of models like GPT-3 and Llama also came on board. Then we'll have the BioGPT, which was by Microsoft, and then the MedPalm by Google that was specialized for healthcare. And from 2023, LLM regulations for AI in medical devices. And in 2024, we saw emphasis being laid on ethical AI in healthcare. Okay, let us watch this video and understand the use of LLMs. Okay, sorry for the network interruption.
It all starts with
Okay, let's do that now. Let's go to the working principles of LLMs in healthcare. LLMs generally use transformer architecture and are trained on massive corpora. Fine-tuning on medical corpora, e.g., like, for example, the PubMed, LLM transformer architecture uses self-attention to process entire sequences in parallel rather than one token at a time. This ability allows it to capture dependencies across long sequences efficiently. They will have the bias mitigation as a challenge. Subgroup analysis and debiasing algorithms are used to curb those kind of challenges. Then for the privacy risks via memorization of PHI, we introduce or inject, we'll do inject what is called noise. Then we'll have federated learning or decentralized training that also helps with privacy, especially when it comes to patient data. Then for the robustness as a challenge, that's when it comes to adversarial attacks. Adversarial testing is usually used as after training the models to also test it on different kinds of adversarial attacks. Then uncertainty quantifications also. Now here is a sample of the transformer architecture. The LLMs usually make use of this encoder-decoder kind of architecture. So most competitive models have the encoder-decoder structure. Here, the encoder maps an input sequence of symbols representations, maps it to a sequence of continuous representations, let's say Z. Then given the Z, the decoder then generates an output sequence of symbols, one element at a time. At each step, the model is auto-regressive, consuming the previously generated symbol as an additional input when generating the next text. The transformer follows this overall architecture using what is called stacked self-attention and pointwise fully connected layers for both the encoder and decoder, as shown in this figure. An attention function can be described as mapping a query and a set of key value pairs to an output where the query, the keys, and then the values and outputs are all vectors. So on the left side of the diagram is the encoder, and on the right side of it is the decoder. So the encoder gets information, processes it, transfers to the decoder, as in encodes it for the decoder to perform and then give you an output. So usually the encoder is bidirectional, while the decoder is unidirectional. The BRT model uses the decoder kind of structure, while the LLMs makes use of both the encoder and decoder. Okay, now the state of the art practices. The current best practices we have when it comes to the biases, the privacy and robustness of LLMs. Google's MedPalm uses adversarial training to reduce bias. For privacy, Hawkins federated learning lets hospitals collaborate without sharing patient data. They will have what is called fairness constraints, a kind of restrictions applied to algorithms to ensure they produce outcomes that are free from bias or discrimination. These constraints are designed to mitigate unfairness in predictions or decisions made by an algorithm, ensuring that certain groups are not disproportionately affected. Then when it comes to the robustness, robust training with adversarial examples, chain of thought prompting is used to help mitigate any kind of or like it's underperformance. When it talks about the robustness, it's kind of describes a situation where your LLM is able to perform perfectly despite all the introduction of noise or adversarial attacks or inappropriate prompting by users. So when it sees things that are not usually in the information it was trained with, it's still able to perform perfectly. Then our stake in healthcare LLMs. At Omife Technologies, we're innovating safe AI solutions for healthcare. As we have the AI-powered telemedicine piloted in Africa, which is our My Smart Medic initiative. Then our project aligns with Unicorn's vision to democratize healthcare access and our mission to drive ethical AI in Africa. It integrates privacy by design, and then the potential product offering of our company, it secures explainable AI diagnostics, and we have the privacy compliant patient data analysis tools as well. Our research and proposed solutions. Ongoing research in bias detection tools for African healthcare data sets. Our proposal involves hybrid model, combining LLMs and local expert systems for robust decision making. They're also exploring blockchain for data privacy enhancements. And for the robust benchmarking, we are evaluating LLMs on noisy EHR data. We're also developing bias auditing tools for healthcare LLMs, while also exploring homophobic encryptions for secure medical LLM inference. Then we'll also be partnering with hospitals for real-world robustness testing. So let's watch this.
Let's play a game.
To understand.
Close your eyes and picture
in LLMs.
A shoe. Okay, did anyone picture this? This? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet. But it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
Okay. All right. After watching that video on biases, like I mentioned earlier about what causes bias, we talked about training data sets. We also said that LLMs are trained on vast data sets, often sourced from the internet or textual repositories. And these data sets may reflect existing biases, such as gender stereotypes, racial stereotypes, or cultural biases. So it is what is there in the data set that introduces the biases to the LLM. Then we talked about the model architecture, where there are underlying assumptions made during its design. So if there are assumptions in the design, it will also affect the performance. They will have the human input, where, for example, the kind of questions the human prompt the LLMs with could introduce bias also. So that's just what the video is kind of explaining. So if there are any questions, the floor is open. Are there any questions? If there are none, I'll be asking questions myself. Okay, the next slide.
What could cause LLMs to display
That's
biases
the number
or
one
produce
question. You have
undesirable
20,
results?
less than 25 seconds to answer.
Place your answer in comments or ask for the answer.
Drop your answers in the comment section or mute yourself and say it if you know the answer. Yeah. Yes, Peace Azupo, you got the answer correctly. Okay, let's clap for her. You got the answer. Manipulated or biased training data set can cause or introduce biases to our LLMs. So the next question.
What architecture do LLMs primarily use? Place your answer in comments or ask for the answer.
The answer also. Yes, everybody is getting the answer. That shows that you are listening attentively. So for the second question, what architecture do LLMs primarily use? So clap for yourselves, everyone. You all did wonderfully well. Okay, so that is it about LLM deployment in healthcare and the challenges we usually face with it, and also the mitigations we have for the challenges that we've been facing. So if you have any questions or want to understand more, I think there are some links added to the slides that you can go through for more self-study, if you please. So thank you for paying attention.